Hope you're all doing well. We're going to take a look at section 8.3 and then follow up with 8.4. I'll make two separate videos on solving quadratic equations. Okay, so if you're noticing, I have a little bit of a different look tonight. I decided to do something I do once or twice a year, and that's just shave off the face and start over. So we'll see if it comes back or not. I just want to see if I was still the same man under all that hair. Now, anyway, quadratic equation. I'm going to show you how to do these. Part of what we do is we do this with factoring. These are x squareds. We also will do it with the graphing calculator. Okay, so we're going to learn some basics about quadratics. We will do that. We will look at using the square root property, which take the square root of both sides. We're not going to do completing the square because we're going to do things graphically, so we don't need to address this. And then we will solve the equation for a variable and look at a few applications of problems where we can use quadratic equations to solve a real world problem. Okay. So what is a quadratic? The defining thing of a quadratic is, I guess up here we could go, is the square. It's got an x squared. So for that reason, that's why they always said a can't be 0, because if a was 0, the x squared part would go away. So remember, a, b, and c are just numbers. Those are the types of variables that are really a constant variable. They're not going to change on us once we know what they are. But they can be different numbers here. So different numbers gives us a different function. So say down in this example of f of x, a is 2 and c is -1. And there are some programs that you have that will solve quadratics for you. One that I'm especially fond of is called Atom Quad for a TI 83 and 84 calculator. If we were in class, I would actually give this to you. Since we're not, it can be downloaded. So if you have an interest in it, I can give you the links to download. But then you also need a cable for installing it. But it's a good program to have when you get into college algebra. Okay. Now, what about b? See, there is no x value here, so you're right. B would be equal to 0. So there's always an a, b, c. Sometimes b or c or both are 0. So over here we have our g of x function, and again, a is the number in front of the x squared. So a equals -1/3. B in this case equals 2, and since there is no number that's just by itself, the c part, c must be 0. Okay. And then we've got h of x where we've got all three of them, and a is here, it's an invisible 1. So a equals 1, b equals 2, c equals -1. Okay. So that's what we call a quadratic equation. The standard form we use is ax squared plus bx plus c equals 0. And you're going to see graphically what we're going to do is we'll get it in this form, we'll get it equal to 0, we graph it, and the solutions, the x values that make this true, are, in this case, the x-intercepts. So there's several different ways to go about this. Section 8.4 will get into something called the quadratic formula, which we start in this form, and again, we're just getting x-intercepts. So that's why these equations are very nice to be solved graphically, because once we graph it, just find the x-intercepts, and we know pretty much everything we need to know about this thing, pretty much. Later on, or maybe not later on, I guess we're ending up here, we could also find, we did it previously, we were looking at the vertex, which is a minimum or maximum. So those really are the things we need, is the x-intercepts, where where the function's equal to 0, those where it crosses the x-axis, and you'll see a lot of applications are things being projectiles, so something going up, that x-intercepts when it hits the ground again, so that's what makes that important. Okay, so the different types of solutions. Again, since we're looking for x-intercepts, and since we get a U-shape, a parabola, we could have no solutions. So here, there's no x-intercept, so we'd say no solutions. We could have the U just sort of what I call kissing the x-axis, just touching it in one place. That's it. That's one x-intercept, okay, one solution. And then we also have where the parabola sort of goes through the x-axis, so we get two solutions, one here and one here where it crosses. But those are the three things that can happen: no solution, one solution, and two solutions. Okay, and we just, how do we know? We graph it and we can look. Two solutions. Wow, one solution. Wow, no solutions. We see it, it's clear, and we just move forward. There's also numerical ways. We'll talk about those, but those are ways that came up 300, 400, 500 years ago before graphing calculators. We still have them around, but we've got graphing calculators and computers that can graph and show us right away. We just got the visual. Much of math can be done in a visual manner now. And not only that, as I've discussed, we have more information by going visual, we have a better understanding by going visual, and it's hopefully easier by going visual. So let's take a look at this. We're going to solve each of these. So I'm going to start with A. Well, we'll start with A. Now they want us to do the symbolic, numerical, and graphical. What I'm going to do, we're going to start with the graphical, and then I'll click through this and you'll see how much time it takes, how much it takes to get the symbolic solution where we've actually already got it with the graphical. The numerical, you start plugging in x values, figuring out y values, you get a table, and that helps you graph it. But again, we've got the tools, so let's do it backwards. Let's graph it first. And I'll go ahead and graph it as y equals 3x squared, what was it, plus 2. So we do that. It's graph. We graphed it. Does this cross the x-intercept? No, it doesn't. Oh, I can't write on this thing, I forgot. But we see there are no x-intercepts. We see it very clearly. If we need some values, we can click here. We get the y-intercept is 0, 2. And again, you can trace along here and get all the values you want. But what we do know is it does not cross the x-axis. So I'm just going to say here, no solution. So look how quickly we did it. Now I'm going to show you the textbook. Okay, so they did this. They subtracted 2 from both sides because they're trying to isolate the x squared. They divided by 3. But then here, you notice x squared is equal to a negative number, which is not possible. When you square a number, you get a positive number, not a negative number. So again, this is a very abstract concept of why there is no solution. But graphically, we could see it very clearly. It does not cross the x-axis, because that's all this equation is saying is there some x value I can plug in here so this graph will cross the x-axis. The x-axis has the equation y equals 0. So that's what that 0 means. It's the y is 0. Okay. So again, we could plug in -1, 0, and 1. Why? They had to have some kind of knowledge, but you can plug any numbers in for x. You get the y value. So notice they plug in -1. -1 squared is 1. 1 times 3 is 3. 3 plus 2 is 5. So that's what they're doing here, is they're plugging them in. Again, I would suggest not doing it. I'd say go directly to the graphical. The reason they needed to do this is so that they could graph it. We're going to have you use decimals or your graphing calculator, so it will produce it directly for you. Okay, and again, by seeing this, we see no x-intercepts, no solution. We're going to do the same thing here. Now I'm going to show you we could graph both sides. I think we've done this before, so I could graph this as one equation, graph this as the other. The solution is where they intersect. Or the more powerful way is what we're going to do is we're going to get this equation equal to 0. How can I do that? Well, to turn one side equal to 0, I add the opposite. Or in this case, since I'm subtracting, I add a positive to both sides. And so what we're going to graph is we're going to take x squared plus 6x plus 9 equals 0. We're going to see if it crosses the x-axis because that's what that's all about. Okay, that's all I had to do. And again, we will just go to the graph. Let's change this to x squared plus 6x plus 9. And look at that right away. We see it does cross the x-axis. It does a little kiss of the x-axis, if you will, touching it at one point, not going through it, but touching it. -3. Our solution is -3. We have our answer right now. Watch what they are going to do from their perspective to get to that. So we know that x equals -3, and we also know there's only one solution. We saw it. How did we know? Very visual. It's there. It's only crossing one way, and then they shoot up and they go up forever. There is a y-intercept, but notice that's not y equals 0, that's x equals 0. And then they just keep going up and up forever and ever and ever, okay, to infinity and beyond. I'd like to go beyond infinity. How about you? Okay, so that's it. Watch what they're going to do. So they did it all in one step. They bring it over. They do the factoring. That's why we taught you all this factoring. But what I'm trying to do now that I've taught you the factoring, I know you guys all learned it, is to show you with the graphing tools, we don't need it as much. It is still helpful. You could see you got this, and then you could solve each one. You get x equals -3. But we got it graphically, and again, the graphical solution provides more details. The equation has one real solution. Okay, here we're kind of like, I always feel when I do this, I'm kind of doing it blindfolded because I get one spot. I go, okay, it's got one solution, but why? When I look at the graph, I see exactly why. And I see that there's other values, but none of them are equal to 0. Only one of them is equal to 0. Okay, so again, they did a table of value, and notice how many calculations they had to do. They plugged in -5, -4, -3, and you could do that right here, do all the calculations, get the y values. They did that, and then they plot these points. Notice the points are plotted, so they've got 4 points, 1, 2, 3, 4, 5 points, sorry, 2 on each side. And that's oftentimes what you need for a parabola. Why did they need to do that? I guess they didn't have access to a graphing calculator or this tool. We don't need to do that. We can go directly from the equation to the graph. And on your TI calculators, the handheld calculators, they also have a table feature, so you could pull up those tables. Again, I apologize, I haven't found one with decimals, and I'm wondering why. There should be that feature where it would give us a table of values, but if you find out, let me know, please. Okay, so that's it. We're going to be able to do all of this simply by graphing. So we've got this one. Let's just graph it, and it will give us all the information we need. So x squared plus 2x, we can just come in here and edit -8. -8. We see it crosses at 2 and -4. Now, what I'm going to show you is that that's actually what would factor. You might have thought of it because all the factoring, 2 times 4 is 8. We're subtracting, that's why the middle term's only 2. But they go through and they do the factoring, x minus 2x plus 4. They solve it. They've got x equals 2, x equals -4. That's what we arrived at as far as the x-intercepts. Notice we could use this process. If you've had problems with factoring, you could graph it, find the x-intercepts, and then sort of backwards solve is what I call it. So I've got x equals 2. So I would get it equal to 0, subtract 2 from both sides. Again, it's kind of strange going backwards, but that's how we find the factors, right? So I'd add 4 to both sides. So notice the factors are x plus 4. The solution is x minus 4. The factor is x minus 2. The solution is x equals positive 2. So there's that kind of opposite relationship between the factor, the thing in the parentheses, and the answer or the solution. Okay. So again, we got it a lot quicker as 2 real solutions. And again, then they go ahead to try to graph it. They plot 5 points. A lot of work, more work than I'd want to do, because we just enter it in and we got our graph, we got our solutions. Okay, you can do that. Now, sometimes Pearson's going to ask you for what it calls an exact solution, and we're going to see sometimes your solution actually might be decimals involving a square root. I'm going to accept your answers, so don't worry. Go ahead and put in decimal answers. Okay, so that's where we're getting to here. If you get x squared equals a number, we could bring that number over and graph it and find all that kind of stuff. However, there's also the square root. If I take the square root of both sides, what I find is that my solution is plus or minus the square root of k, in this case, some number. So let's look at an example. X squared equals 10. So what we're going to get is a square root, or take the square root of both sides. So I'm going to get x equals the square root plus or minus the square root of 10. I've got to remember to get that plus or minus, or let's just graph it. Watch how this works. So to graph it, remember, I would bring the 10 over. I need it equal to 0. So I'll put in x squared, bring the 10 over by subtraction. So it's x, not s, x squared, arrow down, minus 10. And notice I've got 2 answers here. Got negative 3.162, and I've got positive 3.162. What we're going to see is that this number here is the square root of 10. And if you don't believe me, which maybe you shouldn't, we take 10. Where's the square root? Thought I found the square root in here somewhere. Well, we'll raise it to the 0.5 power. A square root is a half power. And also got 3.162. 3.162. And again, we would have to remember that that's plus or minus, but if we do it graphically, we see that it's plus or minus. Okay, so the way they go about it, they just take the square root of both sides, and then they remember when you do that, you get a plus or minus, you get 2 answers, so x is plus or minus square root of 10. This one we can do the same thing, add 16 to both sides. Again, you could also graph this right off the bat. Let's go ahead and do that because that's going to be my preferred way of doing it. Let's come down. We could put in y equals 25x squared minus 16. Okay, and again, since it's equal to 0, what we're looking for is the x-intercepts. And with decimals, you just click on them and it gives it to you. Negative 0.8 and positive 0.8. There's our answers. You can enter those in and you'll be fine. Here, what they're going to do is they're going to add 16 to both sides. Then they're going to divide by 25 to get the x squared by itself. Then they're going to take the square root of both sides, which gives a plus or minus 16 over 25. Square root of 16 is 4. Square root of 25 is 5. 4/5. It's 0.8, plus or minus 0.8. Exactly what we got. But again, I favor the graphing method. This one here, C. Let's go ahead and graph it just as it is. I'll show you how we can do that. It's x minus 3 squared. And again, bring the 16 over. So what we're going to graph, so you're subtracting 16 from both sides, you're going to graph x minus 3 squared minus 16. Nothing more to do. It will give us, because that, right, because this is equal to 0. So when you get it equal to 0, what your solution is the x-intercepts. So we can just go ahead and do these out. X minus 3 squared. Oops, what should do that? Let's go here. Squared minus 16. You see there's two solutions. One's at -1, the other's at +7. Boom, done. Two answers just like that. We could go ahead and write them down. X equals -1 and x equals 7, two answers. Now watch what they're going to do. They're going to take the square root of both sides, which is okay, plus or minus 4, right? That's doable. And then you add 3 to both sides, you get 3 plus or minus 1. 3 minus 4 is x equals -1. Actually, I better not write. They're going to, right? Or 3 plus 4 is 7. So that gives you the plus, the minus gives you this one. Same answers we got graphically. I like graphing. Have I said that before? I hope you like graphing too. We're almost here. So now we're going to look at an example, and we'll see that this is actually a true statement. The effect of gravity is to speed up an object as it falls. It gets faster as it falls. And there's a formula. There's sort of a factor of gravity, at least on Earth, is -16 x squared. And this -16, I think, is feet per second. So if you go to metric, you get a slightly different one. But if you're measuring in feet, you'll see this -16 x squared a lot. This is gravity. This whole thing is gravity. The other thing that starts is, where does it start? How high was it when it was dropped? So if you drop an object h feet, this will give us our equation. So we come to this one. We have some toy that's 40 feet up in the air. Some, I don't know, is that a 4-story window or something? How long does a toy take to hit the ground? Again, we're going to get the formula. It hits the ground when y equals 0. It started at 40 feet, and then remember the equation is -16t squared. This is the number of seconds. When we find the x-intercepts, we'll find two, maybe, we'll see, we'll graph it, but actually just graph it and we'll watch their solution later, because we're going to be able to do this so quickly. We just come in here to our decimals and we do 40 minus 16 x squared. We get it -1.581 seconds. Remember, t is in time. That doesn't make sense. That's before it was dropped. So this one, positive 1.581 seconds. So we could just say here, t equals 1.58 seconds. I think that was right. 1.581. But how accurate could we really be? So this is the equation they come up with, right? The 40 minus 16t squared. That's what we saw on the other page. They got it equal to 0 because we want to know when it hits the ground. If you wanted to know, maybe there was a ledge and it was 10 feet from the ground, you'd have it equal to 10. Then you would subtract the 10, get that part equal to 0. It's all going to work. Always get it equal to 0, graph it, and then your x-intercepts are your answers. Now what they're going to do here instead is they're going to subtract 40 and then divide by -16. And then what are we going to do? We're going to take the square root of both sides. We get this number, which then they plug it in a calculator, or actually do a little bit of work to look at all this extra work. And then they plug it in a calculator, 1.6 seconds. We could have rounded that to 1.6. That would have been fine. But all this work they did, we got it right away, graph it, get it here. And not only that, let me go up here. We actually could look at the whole story here, right? here it is at 40 feet. This is the little toy. Now, this is not the path of the toy, but it is over time. It could have gone straight down, but this is saying as time went on, so like if I'm here, when was it at 35 feet? Well, about half a second, right? About half a second later, a little bit more than half a second later, it was at 35 feet. When was it at 20 feet? Going past grandma's window, I don't know. 20 feet. It took about a second, a little over a second to get to 20. Look at all the information I get from this graph. And then finally, I click here. When did it hit the ground? After 1.58 seconds. So at 1.6 if you want to round it to that. That's pretty quick, but anyway, it's hitting the ground. And again, remember, this is not the path of the toy, but it's time and height. So it could have gone straight down, but this is your time. Okay. And I think that's about it for that 8.3. So get used to using, let's go back to this. I always like this one. I'm standing a little high right now. But keep practicing with the graphing calculator. We're going to take a look, after a little bit of a break, take a look at 8.4. It's a similar type thing. They're going to have you do something called the quadratic formula. I'm going to show you how you can use the graphing calculator to still get the same answers. Okay.